This video is going to go over solving absolute value equations both graphically and algebraically. So let's just go ahead and get started. If you have not already watched the video on how to graph absolute value in general, please go watch that video. Otherwise, you're going to be confused this entire time. So I'm going to start with the second one. Go ahead and find your HK here and here. Remember, x's lie, so my HK is actually at -3, -6. So go put a dot there. All right, now this particular absolute value did not stretch or compress. So it's just going to have a one-to-one slope like this. Rise one, run one. So it looks something like that. Now, you're going to have something that it equals. Like here, it's this -4. You need to imagine that as y equals -4. Y equals -4 is a horizontal line. Looks like this. And so to solve these graphically, all you have to do is go find where these lines intersect. So here and here. And then just tell me the x value for that. So like this one on the left's at -5 and the one on the right's at -1. Those are my answers. X equals -5 and x equals -1. And if I just had to solve this graphically, I would be done. But let me also show you how to do it algebraically. So there's kind of a system I use, and it goes like this. Get the bars by themselves is your first goal. So I'm right here. I'm trying to get these bars as the only thing on this side of the equation. So like this -6, it's got to go. So swing the -6 to the other side by adding 6. So now you'll have absolute value of x plus 3 equals 2. So I got the bars by themselves. Check. Now, the next step is you're going to write it twice. Once normal. And once times -1. Let me show you what I mean by this. I'm going to take this right here. I'm going to drop the absolute value bars. I'm going to write it twice. Once is normal, and then once where my answer equals -1 times whatever was there. -1 times 2 is -2. Now just go solve both. So subtract 3. One of my answers is x equals -1. Subtract 3. One of my answers is -5. Done. And look, they match up with what we got when we did it graphically. So lots of kids, especially absolute value, lots of kids like graphically better. Personally, I like algebraically better, but to each his own. You should know how to do it both ways though. So let me show you number 1, and I'll show you why I did not choose this example. First of all, go graph this. Your HK, your vertex, is at -3, 0 here. And then again, it just has the one-to-one slope. So it's going to look something like this. And then graph what it's supposed to equal. So that's like y equals -2, a horizontal line at -2. The blue line and the orange line will never touch. This is an example of a no solution. And when you do it algebraically, look, if you ever get bars by themselves equals a negative number, it's not possible. It's no solution, because these bars here, the whole purpose of them is to spit out positive numbers all day long. they're never going to spit out a negative number. So if you ever see bars equals negative, you're trying to be tricked. This would be no solution. All right, let's look at some more examples. X plus 6 in absolute value equals 0. Go graph this. My HK is at negative 6, 0. Go put a dot there. Okay, this one looks something like this. Now go graph your Y value that it has to equal 0. This is like it says Y equals 0. It's a horizontal line at 0. Then you just have to tell me where these things intersect. It would be this green dot here at negative 6. So that's my answer. Notice on this one, there's only one answer. It happens sometimes. If I was solving this algebraically, I would want to get my bars by themselves on this left side of the equal sign. They already are. So I'm ready to go to my next step, which was write twice, once normal, once times negative 1. So it'd be like x plus 6 equals once normal, and x plus 6 equals once times negative 1. Well, 0 times negative 1 is 0. So I basically just wrote the same thing twice. I don't need that second one. Just go solve this one. Minus 6, x equals negative 6. And it matches what we got when we did it algebraically. Some more examples. This one, graph this line, find your HK. It's at 4, 3. Put a dot there. And it has a 1 for its slope. So it just looks like this. Okay, and then they want to know where it hits a y value of 3. Well, that's like it says y equals 3, which is a horizontal line at 3. So you can just look at this one and see that they intersect here at an x value of 4. That would be my answer. If I was doing this algebraically, you have to get your bars by themselves. So this plus 3 has to go. So I would minus 3 first thing and rewrite it. Absolute value of x minus 4 equals 0. Now I can write it twice. Once as normal. I don't know why I changed color there. Once as normal. And once times negative 1. Well, this is just like the previous problem. 0 times negative 1 is 0. So we don't need that second one actually on this particular example. Then just solve this, add 4. Okay, I will say that I like algebraically better than graphically, but if it ever equals like an actual line, then I'm kind of split. I like them both kind of the same. Graphically is very helpful when they equal like a line like this. So let me show you how I would do this one. You want to take x plus 4 and find your vertex. So that's at negative 4, 0. Go put a dot there. Then it's the same thing, 1 for its slope. Okay. Then you have to graph this line as if it said like y equals negative 3x. So that would have a y-intercept of 0 and would fall 3, run 1. So it would look like this. And then just find where they crisscross. That would be right here at an x value equal to negative 1. And if you think about it, if you continued these lines, like you kept the blue one going and you kept the orange one going, that's the only place that they're going to intersect, because the slope of this y equals negative 3x is greater than the slope of that blue line. So these things aren't ever going to crisscross again. So this one only has one answer. Let me show you how I would do it algebraically. The bars are already by themselves, so I can go ahead and write this one twice. Once is normal. Once times negative 1. So that negative 3x, when I times it by negative 1, becomes positive 3x. That's how I got this number right here. Now, I would solve both of these. So get all your x's on one side. Get all your numbers on the other. So subtract 4 there. Then divide. And I would get x equals negative 1. Then do it again over here. Get all your x's on one side, numbers on the other. So this one I would minus x. So now you get 4 equals 2x. Then divide. This one I would get x equals 2. Now, you have to, with absolute value, you have to check your answers. You really, really have to check your answers. So like, what I mean by this is take negative 1, plug it in both locations for x. You would get absolute value of negative 1 plus 4 equals negative 3 times negative 1. This side would become 3 equals this side would become 3. Check. I know that answer is good. Now let me check it. Check the second answer. Take your 2, plug it in both locations for x. So you'd get absolute value of 2 plus 4 equals negative 3 times 2. Well, this side's going to spit out 6. This other side's going to spit out negative 6. That does not work. So that means this answer gets tossed. So my only answer is x equals negative 1, which matches when I did it graphically. All right, and then this last problem, I like this example better than the previous one. Basically, graph your absolute value part first. It has a vertex of 0, negative 2. Put a dot there. Then it still just has a 1 for its slope. Okay, and then graph this other equation, 1/2 x plus 1. So y-intercept of 1, rise 1, run 2. This one looks something like this. I'm actually going to continue that blue line a little bit. Okay, now you just have to look and see where it intersects. That would be here. That was kind of off. That would be here at an x value equal to 6. That's one of my answers. And also here, that's an x value equal to negative 2. That's my other answer. All right, to solve this algebraically, you would still try to get your bars by themselves. So the first thing I would do here is add 2. Watch your like terms. So now it's going to become absolute value of x equals 1/2 x plus 3. Now the bars are by themselves, so I could write it twice. Once as normal. And then once as times negative 1. Now that part's going to look like this. If you have 1/2 x plus 3, and you're distributing a negative 1 to that, it goes to both things, okay? So it changes both of those signs. So it becomes like negative 1/2 x minus 3, like that. All right, now go solve both of these equations. So this one on the left, I'd get all my x's on one side, so I'd subtract 1/2 x. This is really like it says 1x. So 1 minus 1/2 is 1/2. So now I'm at 1/2 x equals 3. Times by the reciprocal to cancel this fraction. I'd get x equals 6. That's one of my answers. This other one, get all your x's on one side, so add 1/2 to cancel, add 1/2 x to cancel that. So now it's 1.5 x, which is really like 3/2 x equals negative 3, times by the reciprocal to cancel that fraction. You'd get x equals negative 2, which are the same values I got when I did it graphically. So that's how you solve absolute value, both algebraically and graphically. Graphically, it's pretty easy. If it equals like an integer, like -2, it's a horizontal line. Find out where they crisscross. They're either going to crisscross, or they're either going to not touch, they're going to crisscross twice, or they're going to hit just once. And then algebraically, get the bars by themselves, write it twice, once normal, once times -1. And when you write it twice, drop the absolute value bars, then you go solve both. So hope this video helped.